Alright, this is Mr. Martin. These are the video notes for section 6.5 for Precal Honors. This is day 2. I'm going to call this video part 1.5 because part 1 video was going a little bit long, so I figured I would just finish it up with a short video to talk about the definition of an nth root of a complex number. So we're going to get up to roots of unity, and then roots of unity will be covered in the next video, part 2. So day 2, part 2. So we've got a complex number. We're going to call it u, and it's going to be a plus bi. And this number is an nth root of the complex number z if z is equal to u raised to some exponent, which is a plus bi raised to some exponent. So I know this gets kind of confusing, but really we're just looking for roots. In this case, we're looking for complex roots. So if the complex number z written in trig form is r times cosine theta plus I sine theta has exactly n distinct nth roots, and the n distinct nth roots are given by this formula. Okay, so this is a formula to find the nth roots of a complex number. Okay, and then you'll notice we have a value k here. K starts at 0 and goes up. Okay, so if we're looking at fourth roots, we would have 0, 1, 2, and 3. Okay, like we're going to have in the next example. Alright, so maybe you want to think about this when we looked at the other example, when we had we were finding the roots of 16. We had 2, negative 2, the fourth root of 16, 2i and negative 2i. Really think of this as a complex number, and we're finding the roots for it. Okay, and really using this formula we can find any number of roots that we would want to. So let's take a look. I know this formula looks scary, but once you get into it, it's really not that bad. We want to find the fifth roots of 4 plus 4i. Alright, so since we want the fifth roots, we're going to have k is equal to 0, 1, 2, 3, and 4. Alright, and we're going to need to know what r is. So r is going to be the square root of 4 squared plus 4 squared, so that's the square root of 32, and we'll leave it like that for now. And we're going to need to know what theta is. Theta is going to be the tan inverse of 4 over 4. So we know that's in the first quadrant, and that's going to be pi over 4. And so we've got r, we've got theta, and we've got n is equal to 5. Okay, so we're going to use our formula up there, and we're going to use that formula actually 5 times for the 5 roots. Alright, and we're going to start with k is equal to 0. So k is equal to 0. So I'm going to have the fifth root of 32, square root of 32, sorry. Sorry, that should be the fifth root of the square root of 32. Okay, and then times the cosine of theta, which is pi over 4, plus 2 pi times our first value of k, which is 0, divided by 5, plus I times the sine of pi over 4 plus 2 pi times 0 over 5. Okay, so the fifth root of the square root of 32 is going to be the square root of 2. And if we simplify all of this stuff, I have pi over 4 plus 0 over 5. So that's going to be the cosine of pi over 20 plus I times the sine of pi over 20. So this gives us our first root here, and then we're going to do this 4 more times. Okay, and after a while you should see a pattern forming. Alright, so next we're going to do for k equals 1. K equals 1. So again, I have the fifth root of the square root of 32 times the cosine of pi over 4 plus 2 pi times 1 over 5 plus I times the sine of pi over 4 plus 2 pi times 1 all over 5. And again, I'm going to get the square root of 2. And if I've got pi over 4 plus 8 pi over 4, which is 9 pi over 4 divided by 5, which is 9 pi cosine 9 pi over 20 plus I times the sine of 9 pi over 20. So there's our second nth root. Alright, now let's move on to k is equal to 2. So I have the fifth root of the square root of 32 times the cosine of pi over 4 plus 2 pi times 2 over 5 plus I times the sine of pi over 4 plus 2 pi times 2 over 5. And we're going to get, again, the square root of 2 times the cosine. So now I've got 4 pi plus pi over 4, and that's going to give us 17 pi over 20 plus I times the sine of 17 pi over 20. So there's our third. And then if you want to go ahead and work through the next two, you can pause the video now. Otherwise, I'm just going to put in the final answers for k is equal to 3. Pause if you don't want to see. You're going to have the square root of 2 times the cosine of 25 pi over 20 plus I times the sine of 25 pi over 20. So this is our fourth. And since we wanted to find the fifth root, we need one more. So for k is equal to 4, you should have gotten square root of 2 times the cosine of 33 pi over 20 plus I times the sine of 33 pi over 20. So keep in mind that our answers here are in trig form or polar form, and if we wanted them in standard form, we would just use our calculator because these are not special angles, and then we'd figure out what the cosine of 25 pi over 20, for example, is and multiply it by root 2, and then figure out what the sine of 25 pi over 20 is and multiply it by root 2. So these are the fifth roots of this complex number. Okay, so make sure you're doing enough practice so you get proficient with the formula for finding the nth roots. And again, if you have any questions, make sure that you ask, and we will see you next time.